Hey, what's going on, my MathCounts people? So we've got from 2026, we've got the simplifying radical stretch. I did make a separate video just on some instruction on this. The worksheet itself does give a little bit of instruction, but I go into a little bit more detail on my video. So jump over to that video if you want to know more about simplifying radicals. Here we go. You know the deal. Try out the problems yourself before I give you the answer. Let's do it. All right, so what is the square root of 8 expressed in simplest radical form? So remember, simplest radical form doesn't have any factors that are perfect squares. And inside of 8, we do have a factor that's a perfect square. So we've got root 4 times root 2. So we're splitting up square root of 8 into root 4 times root 2. Root 4 is a perfect square. That makes 2. So 2 times root 2 is simplest radical form for this. So we would write 2 root 2, or 2 times the square root of 2. Next one is a cube root. So on the cube root of 81, we have to remember that we're not looking for perfect squares anymore. We're looking for perfect cubes. So there's a couple ways you can do it. You can either know that 81 is 27 times 3, or you can kind of just break it down here. So we got 9 times 9 is 81, and we got 3 and 3, and 3 and 3. So 81 is 4 threes. So in order to be a perfect cube, you need to have 3 numbers multiplied by themselves. So here I've got 3 threes. So this would be 3 times 3 times 3, 27. So that would be equal to 3, and then left in the root, I still have a 3, but remember this is the third root. So this would be 3 times the third root of 3. The other breakdown would be like this. If you realize that you've got, 27 times third root of 3. Fingers aren't working today. So the third root of 27 is 3, and then we've got the third root of 3 left over. So 3, third root of 3. Don't forget the 3 in the index up there. Still has to be there. All right, next one, number 23. Square root of 150 minus the square root of 24. So we got a little bit of a problem here. They are not like terms because the radicals are not the same. But we can simplify both of these and then find out the radicals are the same. So for this one, I can see the perfect square inside of there. This is 25 times 6. 25 is 5 times 5. So I got a pair of 5s and a 6 left over. The 6 is a 2 and a 3, but there's no pairs there. So the square root of 150 would be 5 root 3. No, 5 root 6. Jeez. 24. I can tell that 24 is 4 times 6. So I got a pair of 2s here. So the square root of 4 is 2. And then 6 is just 2 times 3. There's no pairs inside of that. So I've got 5 root 6 minus 2 root 6. So if I got 5 root 6s and I take away 2 root 6s, I would have 3 root 6s left. All right, next one. Root 3 times over 2 times root 6 over 3. Okay, radicals can multiply with other radicals. So since this is a multiplication problem, I can start by multiplying going straight across. Root 3 times root 6 is root 18. 2 times 3 is 6. But this is not simplified because root 18 can still reduce because it has a perfect square in this. We would have the square root of 9 times the square root of 2. The square root of 9 is 3. So the numerator becomes 3 root 2. The denominator becomes 6, but wait. The 3 and the 6, the coefficients here, they can reduce. So our final answer would be 1 times root 2, or just root 2 over 2. Next up, what is 1 over root 7 expressed as a common fraction in simplest radical form? So one of our rules for simplest radical form is we cannot have a radical in the denominator. So we are going to rationalize the denominator, which means we're going to multiply by 1 in a little tricky way. We're going to multiply by root 7 over root 7. This is called rationalizing the denominator. 1 times root 7 is root 7. And root 7 times root 7 is like squaring root 7. That's just going to be 7, because remember, root 7 times root 7 is root 49, and that's the perfect square of 7. So anytime you square a square root, the root just basically goes away. You get 7. So we've got root 7 over 7 for that one. All right, down to where you start doing some conjugates. Let's do these. So again, we have a radical in the square root, but there's a binomial down there. So that's a little bit problematic. So we can't just multiply by root 2, because if I multiply this one by root 2, the radical does go away. But then if I multiply this one by root 2, the radical doesn't go away. So we have to multiply it by its conjugate. The conjugate of 3 minus 2 root 2 would be 3 plus 2 root 2. This is also known as using the difference of two squares. So I have to do it to the top and the bottom because I'm multiplying by 1. So in the numerator, I get 1 times 3 plus 2 root 2, which is just 3 plus 2 root 2. In my denominator, however, remember, if you use an area model for this one to multiply it out and see what's happening with the numbers, you can see that our radicals are going to cancel out in these diagonal right here. So we got 3 plus 2 root 2. So 3 times 3 is 9. 3 times negative 2 root 2 is negative 6 root 2. 3 times positive 2 root 2 is 6 root 2. And you can see these are canceling each other out. And then 2 root 2 times 2 root 2. Okay, so 2 times 2 is 4. Root 2 times root 2 is 2. So I got 4 times 2, because 2 times 2, 4. Root 2 times root 2, 2. And then we also have the negative. So this is going to be negative 8. So in my denominator, all I have left with is 9 and negative 8. 9 minus 8 is 1. So my final answer is 3 plus 2 root 2. Next. All right, so this one is probably a trick question for some of you. You may be tempted just to multiply 2 times 2 and get 4, and negative root 2 times negative root 2 and get positive 2, but that's not how it works because this is a binomial. Now in our denominator, I can do 2 to the second and get 4. But if we look at an area model, we see that this doesn't work. So if I take 2 minus root 2 squared, that's the same thing as saying 2 minus root 2 times 2 minus root 2. 2 times 2 is 4. 2 times negative root 2 is negative 2 root 2. 2 times negative 2 root 2 again is negative 2 root 2. And then negative root 2 times negative root 2 is positive 2, because root 2 times root 2 is 2, and a negative times a negative is a positive. So looking at these two diagonals, 4 plus 2 is 6. Looking at these two diagonals, I've got negative 2 root 2 and negative 2 root 2. That makes negative 4 root 2. So only the coefficients are combined for this. The radicals stay the same. So we're not quite done because I noticed that my coefficients of 6, 4, and 4 can all be reduced by the same number. So 4 can be reduced by 2, 4 can be reduced by 2, 6 can be reduced to 3. And so our final answer would be 3 minus 2 root 2 all over 2. You can only reduce like this when all three of these numbers reduce. So we got 3 minus 2 root 2 all over 2. Whew. All right. It's getting fun. Next one, 3 plus root 2 over root 2. So it's not simplified because we have a radical in the denominator. So we're going to rationalize that denominator. We're going to multiply the numerator by root 2 and the denominator by root 2. In the denominator, root 2 times root 2 is just 2. And then over here, root 2 times root 2 is 2. And root 2 times 3 is 3 root 2. So we have to distribute the root 2 to both of these. It wanted them in this format where the integer was first and the irrational number was second. That's why I did it in that order. So our final answer is 2 plus 3 root 2 over 2. $29. Root 7 plus root 5 times root 7 minus root 5. So you might notice that this is the difference of two squares. So what you could do is just do root 7 times root 7 is 7. And root 5 times negative root 5 is negative 5. And we got an answer of 2. If you didn't see the difference of two squares, you would probably want to do an area model instead. So the area model look like this, where we're doing 7 plus root 5, root 7, and root 7 minus root 5. So root 7 times root 7 is 7. Root 7 times root 5 is root 35. Root 7 times root 5 is negative root 35. And then root 5 times root 5 is 5, but we got a negative times a positive, so that's negative 5. And here we can see that the root 35s, one's positive, one's negative, so they cancel. So we're left with 7 minus 5, which is 2. All right, and now the funnerest one of them all. I'm going to need an extra piece of paper here. Okay, so here's our last problem. 1 over 1 plus 1 over 2 plus root 3. Oh, this one's delicious. All right, so here's what I would do first. I'd deal with my denominator here. I can't combine them until they have a common denominator. Their denominator here is 2 plus root 3, so I can change 1 into 2 plus root 3 over 2 plus root 3. See what I did there? So this 1 became 2 plus root 3 over 2 plus root 3. Now we have a common denominator, so we can combine our numerators. So we end up with 2 plus root 3 plus 1, which would be 3 plus root 3. Because we're adding, so we get a common denominator, and the common denominator is 2 plus root 3. Now when you have a fraction inside of a fraction, in the denominator, your denominator would then move to the numerator. So 2 plus root 3, we're going to multiply by the 1 up there, and it's just going to be the same thing. So we're going to, if you've got a fraction inside of a fraction, the denominators move to the other part. So if you had a denominator up here, you can move it down to the denominator down here. So I'm going to move this to the top, and now I've got 2 plus root 3 over 3 plus root 3. Okay, I'm still breaking my rules. I have a radical in the denominator, so I'm going to end up using the conjugate. I'm going to multiply by 3 minus root 3. All right, since we have binomials here, we're going to have to use an area model. So I'm going to do the numerator first, 2 plus root 3 times 3 minus root 3. 2 times 3 is 6. 3 times root 3 is 3 root 3. 2 times negative root 3 is negative 2 root 3. And root 3 times root 3 is 3, but it's going to be negative because we have a negative there. So that's going to be negative 3. So in my numerator, the 6 and the negative 3 here make 3. 3 root 3 minus 2 root 3 makes positive 1 root 3. In my denominator, this is the difference of two squares here, 3 plus root 3 times 3 minus root 3. We get 9, 3 root 3, negative 3 root 3, and negative 3. These cancel, and I'm left with 9 minus 3, which is 6. I can't reduce, the 3 and the 6 reduce, but the coefficient here is 1, and the 6 isn't going to reduce with that one. So my final answer is going to be 3 plus root 3 over 6. Wasn't that fun? The end. That is everything that you need to know about radicals. Math hard. I will see you guys later. Bye-bye.